Okay, this is the second class of this week, week 6. This is business analytics class. Okay, now we're gonna learn about the hypothesis testing. We just brush up what I learned in the statistics. I think that before you take these classes, I heard that some of you are already known about the statistics, terminology of statistics, and the theory of the statistics, I think. However, before moving on, we are going to learn about the regression, multiple regression, and also classification. Before we move on, we have to be familiar with hypothesis testing. Okay? Okay. Uh, as you might know, before moving on, you have to know the distributions first. Okay, distribution. What is distribution? This definition of the distribution is a function shows actually showing the possibility values for a variable and how often they occur. Okay, usually we draw the normal distribution is a symmetry. Okay, this is mean. We call it mu. Okay, normal distribution is a probability distribution, and also this is a density, density function. Okay, density function. So the total of the probability, as you might know, this density is 1. Don't forget about this one. In case of the normal distribution, this is traits, two traits, are perfectly symmetrical, and the most probable values are around the mean. This is mean. We call it mu. Okay, the next one, we move on G-score. I briefly mentioned about this one, G-score. G-score, because we have the kind of mu, several the normal distribution, but we want to standardization, want to standardize the normal distribution. How can you do that? We change it into standardized variable g. G is, as you might know, the formula is like this way. Hold on, please. Sorry of this. G is original variable. We call it x minus mean x bar. Right? This is g, and the standard deviation like this one, right? Don't forget this formula. No, not this one. So this. So actually, original variables minus mean divided by standard deviation. We have to figure out and distinguish standard error and from the standard deviation. Okay, standard error and the confidence intervals. Standard error, standard deviation means a measure of variability. Okay, standard error is a measure of the variability is the same, but on a larger scale. This is different. Okay, let's move on. The next one is, as you might know, population. We extract something. We call it, this is a sample, right? Population versus sample. Actually, as you might know, more sample means that their average is closer to the population mean. Look at this. If you have a sample with over 30, more than 30 observations, you can accept that the sampling distribution with mean equals to the population mean. So if you have if it more than 30 samples, it is closer to the population mean. Okay, with a mu. This is an x bar in the sample. This is population. So if you have the more than 30 samples, it is closer to the population mean. Okay, don't forget about that. So the more samples is actually it's closer to the population mean. Okay, now equals to. So the standard error means standard deviation of the sample error. Standard deviation gives us the level of the certainty, with which we can generalize from a sample to a population. Okay, sample error. So actually, if the standard error is lower, the lower standard error is actually the accuracy it will be of the sample is increased. Don't forget about this one. Confidence level. Confidence level, because if we get the kind of result mean from the sample, actually it's not accurate itself. However, so that's why we need kind of the range of this. We call it this confidence level. Confidence level is a range of the values, okay? The range of values where the population mean is likely to fall into. Okay, so this one is a lower boundary. This is mean, mu, or x bar in case of a sample, and the lower boundary is upper boundary. Okay, example, x bar. Actually this is the confidence level -2, or x bar -2, or x bar -2 +2. This is the confidence level. This is a range. So we did not like this way. I think that you are familiar with this one, right? Before, okay, I will show you this one. Okay. Hypothesis. Okay. Before moving on, I will do this one first. Okay, steps in data-driven decision making. The first of all, the research question. The second step is generated the theory, and the third step is formulate a hypothesis. Like this is null hypothesis, and this is alternative hypothesis. I will explain in detail. After that, we find the correct test. Usually we call the G-test, or with the p-value, we find the correct test. After that, execute the test like this way. After that, we make the decision right this way. Please, like this kind of step. Okay, step of data-driven decision making. Okay. Hypothesis. What is the hypothesis? A hypothesis is a statement. It should be statement. Statement that can be tested. Okay. So we call it like this one. H0 means the null hypothesis. Is what the theory predicts will be false. Okay. We are, as a kind of the researcher, we want to reject this null hypothesis. Okay, actually, for example, I mentioned about the Shincheonji is one of the kind of the immoral, immoral kind of we call it Saibi, actually, the religious group. So actually, they As you may know, if you heard of from the news, actually one of the causes of the coronavirus in Korea. So 70% of believers, this is a kind of statement, right? 70% of the believers of the Shincheonji have caught coronavirus. This is a kind of statement. This is H0. This is null hypothesis, but some researchers denied this one, like this one. Actually, 70% H0. We make this one. Actually, as a researcher, we cannot prove, but we want to reject this one, like this way. So the researchers' objectives like this way. H1 way out, or we not like this way. The alternative hypothesis, what the theory predicts will be true. So we make this one kind of the statement. Actually, 70% of the believers of Shincheonji, this religious group, don't have caught coronavirus. H1, and like we make like this one. This one means not 70%. Actually, we cannot prove of this whole sentence because we just predict. So, but we wanna reject this the null hypothesis. After that, automatically you support this alternative hypothesis. Okay, this is the researcher rule. So with this one, hypothesis is an idea can be tested. Okay, it is a supposition or a proposed explanation made on the basis of limited evidence as a starting point for further investigation. Is we call it this one is null hypothesis. Actually, we want to support this alternative hypothesis. Okay. On this one. Okay, now this is the I think right the hypothesis like this way. Example one. The maybe you wanna be a data scientist, right? In the business domain. The actually salary maybe you can get you wanna get the kind of the higher salary. So each, for example, you investigate the salary of the data scientist in the US. Look at this. The mean data scientist salary is $113,000. Then we try to reject the null. This is the null hypothesis. The data scientist, the mean of data science salary is more than $113,000. We want to reject this hypothesis. Yeah, in case of this, we want to make this one. No, it's alternative hypothesis. The mean of the data scientist is not what? Salary is not $113,000 like this way. This is alternative the hypothesis. Okay, here's a good example though. Before moving on, I will explain this one. Type 1 and type 2 errors. Type 1 error means rejecting a true null. Another name is a false positive. Actually, we call it probability is alpha. Type 2 error is accepting a false null, false negative. Probability is beta. Okay. Might be with this one. This one. This is a type 1 error and type 2 error. Okay. Before moving on, I will explain decision intent tag like this way. Actually, this is a normal distribution, right? You can accept or hypothesis or reject the null, okay? Actually, this is the assume this is H0 null hypothesis. This is we make that kind of 95%. This is G score is 1.96 is minus 196 like this way. If this is a density, this is kind of part of the accept, right? The null hypothesis, but this two side, this is a region of the rejection. Okay, if you're the kind of look at this at X% of significance, we accept the null hypothesis here. Okay, but and in case of the your data, the score of your data is here. Might be we rejected the null hypothesis because this is a rejection region. Okay. So common significance level. This is alpha. Is 0.1 meaning that is 90% of the confidence level. This is a 95% confidence level. This is 99% confidence level. So alpha we learned in case of the 95% of the confidence level, alpha is 0.05. But it is a two sides the testing, the two-tailed test. Actually, we divide by the 2, right? Because it's two tails. So this one will be, don't forget about this one is the density of this whole distribution, right? There is a 0.025. This one is also 0.025. Don't forget this. This is one side one, but this is more strict. Okay, this is a time one error, time to error. I will mention about this one. Look at this. X0 is true. So that we accept this one. Is the right answer true? X0 is a null hypothesis is false. So we reject this one is true. So our interest is here. This region. These two parts, right? So as I mentioned, what if a null hypothesis is true, but we rejected this one? This is error. Is we call it type 1 error or false positive. Okay. Then another one, type 2 error is null hypothesis is false, but we accept it. There is a false negative. You know what I'm saying? So, okay, don't forget about this one. The probability of the committing type 1 error, false positive, is equal to significant level is alpha. We call it alpha. And the possibility of the committing type 2 error, false negative, is equal to beta. We call it, and called the power of the test. This is a p-value. P-value is the smallest level of the significance. This is a significance, which we can still reject the null hypothesis given the observed sample statistics. Notable p-value, we use this one. Actually, if you use a kind of the statistics, the programming, like R programming or Python, actually, as a result, you can get the kind of this result like this p-value, meaning that this one 0.0000 like this way. When we are testing the hypothesis, we always strive for those 3 zeros after the dot. Actually, we can't reject the null hypothesis at a significance level. The significance level is maybe we can't set it kind of 95% or 99% like this way. And if you see this one, 0.05 is often cutoff line. Okay, if our p-value is higher than the 0.05, we would normally accept the null hypothesis. So p-value, we can get that the p-value is smaller than the 0.05. We can reject the null hypothesis, and meaning that another meaning of this, in other words, we accept what or support alternative hypothesis. Okay, so if the p-value is lower than the 0.05 like this way, we would reject the null and accept the alternative hypothesis. I think that you are already familiar with this one. So some of you ask me that what is a p-value? Actually, p-value, if you are g-score, okay, if you get the g-score, actually, if you have the textbook of statistics, actually there is a g-score table like this way. In this table, you can get the kind of result. Okay, actually, this is a p-value. P-value is like this way. This is a normal distribution. As you see, these two regions, in case of a two-side test, okay, these two part in the normal distribution is a rejected region, right? So this we get the kind of g-score. If our g-score is this in this rejection region, we reject null hypothesis. So p-value would be here. Assume that the null hypothesis is right. However, p-value means is definitely very smallest level of significance, so it should be in the rejection region in case of the null hypothesis is right. Okay, so definitely is smallest significance. So meaning that if this is also the, look at this, I magnify this part here. This is a rejection part. Okay, this is a rejection part. We have g-score here. The p-value, this h0, no hypothesis is right. Assume that. Okay, the p-value here, this is the smallest level of significance. Also, this is density. Okay, might be p-value compared to 0.05. P-value is smaller than the p-value is lower than point, like this way, meaning that this density of the p-value is only just here in the rejection region. Now you can get it? Okay. Okay. Move on this one. Okay, now before it makes you crazy, I think. Anyhow, now, so we wanna standardize the normal distribution because to compare and also to standardize. So g-score like this way: g x minus x bar in the sample and squared standard deviation. This one is g-score. Okay, so g-score is mean if you standardize this normal distribution, the x bar is 0, the standard deviation is one. This is a standardized one. This we call G normal distribution. So standardization is let us compare the means. Okay. This is important. Okay. So now with R programming, we'll use this one. For example, we have the kind of the data scientist group. We at 0 is the salary of the data science group in the US. They get their can say this one. They will get like this one. We heard them use like this way. The null hypothesis in general, the mean of the salary of the data scientists in the US, they earn the money $113,000, and the standard deviation is $15,000. But we want to reject this null hypothesis in the case. Okay, we just the more than 30 samples, we experiment to support to reject this null hypothesis. Okay. Okay. The sample means is $200,000. Population standard deviation is $15,000. Standard error is $2,739. Sample size is G-score is minus 0.67. Assume that at 0 hypothesis, null hypothesis is $113,000. Two-side test. Okay, this one normal distribution, and this is two rejection region. Okay, please open this file. This.csv, salary.csv, and it goes to we just variable cell. Then look at this one. This is if you type the summary function, you can get this big 5. Big 5 is this one, minimum and maximum. And first quartile, if you remember the box plot, right? This is a median, right? Median, and the mean is really important things. Actually, this is first quartile, this is third quartile, right? Like this way. This way is we call it in the statistics big 5. This is a very important the explanation of the element of the data. Okay. Read this one. Actually, in algorithm, there is no the G-test module, but it's super easy to make it like the Agile user function. Using the user function, we call A, mu, standard deviation. We input the kind of this data. After that, look at this. This is a formula, right? So mean A, right? Mean A minus mu. You are familiar with this one. After that, this one, right? Standard deviation. Standard deviation, and this one, right? Length A. After the return G. Okay. So you keep that this code to use the G-test for your individual assignment and midterm exam. Okay. Use this code. Okay, this that. Now we input our the data. A is salary is as you might know, you wanna access to the variable in this data set is salary, and mu is as you might know $113,000. This is null hypothesis inform you of this data, right? The standard deviation is $15,000, right? After that, you enter this one, Control Enter. What you're gonna do? Actually, you can get this result. You have to interpret this result. Actually, this result is like this way. So, if you change this one, G-score, this 4.67 is a high, is larger than the G point. Actually, G is absolute value of the G score. Actually, should be is spelling should be higher than the absolute value of G. So, alpha, as you mentioned, we have 95 confidence level. Alpha is 0.05. So, in that case, we draw this normal distribution is with 95% confidence level is alpha is 0.05, right? It's a two slide, each one 0.0025, right? This is a density. Don't forget about this. Each one. This is a rejection region. Okay. After that, anyhow, in that case, in the 95 confidence level, this is one. This mu. This one, in case of this G, is the G score is 1.96. As you may know, minus 1.96. So look at this. In case of this, our result 4.67 is larger than G, right? Where G is 1.96. So therefore, the null is rejected. Okay. I already explained this one. So, hold on please. This is the end of the second class.